This is Mr. Martin. These are the video notes for Pre-Calculus Honors, Section 8.7. We're going to finish talking about probability in this video. So the first topic we're going to talk about are mutually exclusive events. So two events, A and B, from the same sample space are mutually exclusive if A and B have no outcomes in common. In other words, the intersections of A and B is the empty set. Okay, remember this symbol means intersection. So that would mean that the probability of A and B happening at the same time would be 0. Okay, so if A and B are in the same sample space, then the probability of A or B happening, so the probability of A or B, is equal to the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring. So this is when they would occur at the same time. So this is their overlap. And you need to make sure that you subtract when they're happening at the same time. And when we look at an example, I'll point that out again. Now, if they are mutually exclusive, they do not have any outcomes in common, it becomes a little bit easier to figure this out. It's just the probability of A plus the probability of B. Okay, we don't have to worry about any intersection of the two probabilities. So let's take a look at an example where the outcomes are not mutually exclusive. I think this will help explain it. So one card is selected from a standard deck of 52 playing cards. What is the probability that the card is either a club or an ace? So the probability of an ace or club is going to be the probability that we pick an ace plus the probability that we pick a club, but then we need to subtract the probability that it's an ace and a club. Okay, so that's the key there, and. So the probability that it's an ace, there are 4 aces out of 52. And the probability that it's a club, there are 13 clubs in the deck out of 52. And then we need to subtract out when it's an ace and it's also a club. So there is 1 ace in the deck that's also a club, so that's 1 out of 52. And if we add and subtract, we get 16 out of 52, which reduces to 4 out of 13. So I think that's a good example to see how we need to subtract out the union. Alright, next we're going to talk about independent events. So if A and B are independent events, the probability of both A and B will occur as given by probability of A times probability of B. And we've talked about this before. Also, let's say we're tossing 2 separate coins. Those are independent events. Or let's say we're tossing a coin and then rolling a die. Those would be independent events. So for the next example, we've got 2 integers from 1 to 30 are chosen by a random number generator. So this would seem to indicate that we could get the same number more than once. Okay, that would be considered with replacement. So what is the probability that both numbers are less than 21? So the probability that the first number is less than 21 would be 20 out of 30. There are 20 numbers less than 21 from the numbers 1 to 30. And then the probability that the second number would also be less than 21 is 20 out of 30, which when we reduce gives us 4/9. So the probability that both numbers are less than 21 would be 4/9. Alright, moving on to another example, talking about independent events. A sales representative makes a sale at approximately 1/3 of all calls. If on any given day the representative contacts 5 potential clients, what is the probability that a sale will be made with each of the 5 contacts? So since he's going to make a sale approximately 1/3 of all calls, and he's going to make 5 calls, it would be 1/3 raised to the 5th, or 1 out of 243. Okay, that's the probability that a sale will be made with each of the 5 contacts, because with each contact, the probability would be 1/3, and then he's going to call 5 people, and they are independent events. So when we talk about the complement of an event, it's the collection of all outcomes in the sample space that are not in A. Alright, so A prime is the complement, and the probability of A plus the probability of the complement of A is going to be 1. Right, so the probability of the event and the probability of not the event happening is going to give us the whole sample space. Or you could think about the complement being 1 minus the probability of the event. And the reason we talk about this, it seems a little convoluted, but sometimes it's easier to think about the complement of an event in order to determine a probability. Okay, so in this last example here, a sales representative makes a sale at approximately 1/3 of all calls. If on a given day the representative contacts 5 potential clients, what is the probability that a sale will be made with at least 1 contact? Okay, this at least is important because when we say at least 1, we're talking about either 1 contact, or 2, or 3, or 4, or 5 sales. Okay, so really we would have to take into account each and every one of these different cases of number of sales. So what it might be easier to do is determine the probability that he does not make a sale, so no sale. And then if we subtract that from 1, so this would be the complement of at least 1, this would be none, then we can find the probability of at least 1, which would take into account all of these. So if he's going to make a sale 1/3 of all calls, that means that 2/3 of all calls he will not make a sale. So that would be 2/3 for each call. He's going to make 5 calls. Therefore, the probability of at least 1 sale would be 1 minus the probability of no sale, which is going to be 1 minus 2/3 to the 5th, which ends up being 211 out of 243. That's at least 1 sale. And so there's a little example of how the complement of an event can make things a little bit easier. All right, again, if you have any questions, make sure that you write those down and ask me when you see me in class. And we will see you at the next video.